Hello, my name is Mohsin. I just really wanted to quickly show you guys some demonstration and some impact of performance when it comes to vector search for images. And before anything, I just really wanted to show you some real life examples of how vector images or vector searches work for images. So one of the examples is how with Google you can do image searching, right? So I'm just going to upload a file of iPhone, and yeah, it's going to find me like similar images and similar products. So this is one of the cases where vector search is used for image searching. And for another one, which is a very interesting case, I found this application. It's called Same Energy. It was recommended to me by a friend. And if I click on any of these images, for example, this black-handed one, I'm getting like very similar pictures with similar vibes. So these are the practical examples of where image searching is used via vector searches. So in these scenarios, these companies are using something like Pinecone or something like Chroma in their backend in order to do similarity searching throughout their image database, right? So I'm just going to show you how performance really affects and how does it scale to, for example, let's just say billions of images. So I'm just going to go towards this repository, which is basically the Antarys benchmarking repository. You can just download it. The installation and the steps to get started is already there, right? So first of all, I need to start the Antarys server. I already have the command written down. You can just copy it. It's also on the documentation side, so you don't really have to manually type it in. You can just go there and just paste it on your terminal. I'm just going to start the server. And this is basically the project you get when you clone the repository. So it's a very simple application that basically extracts the features from the images and saves them into vector dimensions to the vector database. So I'm going to start running this test. So I'm going to query for 100 images, similar, and the input image is of a dog, and we are going to get like similar dog pictures out of it. So yeah, I'm just going to run it. It's going to take a while to extract all of the features, then store all of the data into the vector database itself, and yeah, run the query. So it's going to take some time. Okay, so the query finally ended, and as you can see, the input image was of a dog, and I got similar dog pictures as a result, right? So the query happened within 0.0026 seconds, so it's very fast, so almost 26 milliseconds. So that's sub 50 milliseconds, so that's almost real time. Okay, so now we're going to switch back to Chroma, and we're just going to run the exact same test with the same input, and we're just going to see how does it perform. So we are going to have to open up the image similarity test, yeah, and then we're just going to run it. So we are running the script, and again it's going to take some time, so I'm hopefully just going to skip this bit so you don't have to see the awkward pause. So yeah. So the query actually is done. As you can see, I am pretty much getting the same result, because the way that this data works is that all of the vector dimensions, they have been set in a way where it's very consistent over any of the tests. So how do you reckon your database is working correctly is that you're going to get pretty much the same sort of result or same structured result from every other vector database. So yeah, this is very good, and this is by Chroma, and as you can see that the query executed in 0.043 seconds, and that's absolutely fast. It is sub 50 milliseconds, so that's almost considered real time. But the problem is Chroma is almost twice as slow when it comes to image searching than Antarys, and Chroma is supposed to be one of the most fastest vector database out there. So if we scale this over to other vector databases, we're going to see very similar results. For Milverse or Pinecone, they're just going to be much slower than what Antarys is performing. So you might be wondering, like, how does this really affect performance in a whole? Because we are only querying like 100 images, but for major companies like Google or companies like Pinterest, they use vector search over billions of documents. So just imagine scaling this to from 100 to billions of images. So the difference in performance is just going to be extremely impactful. So this is where Antarys brings in the value for vector searches, and this really changes how performance can impact your server costs. So for example, just because we are pretty much performing almost twice as good as the other vector databases, and I, of course, am not going to run all of the vector databases. The result is already uploaded on the main website. You can go to antarys.ai/benchmark to be able to see how we are performing. So imagine running this sort of queries over let's just say 100 million images. So these are very normal cases for very big corporations. So this is not only applicable for images. You can pretty much do vector searches for texts, right? So you can also do it for text. You can do it for audios. This is how Shazam works. This is how Spotify knows what sort of music that you're going to like, because it's very similar to the music that you are listening to. So similarity searches are everywhere. It's very important. It's very crucial. So this is where Antarys really adds in the value of that extra performance benefit. So yeah, this is what we are sort of doing, and of course we're also working on bringing in much more better performance, much better toolkits for building much more faster and much more efficient AI applications that can pretty much run anywhere. So this is basically what we're doing. So thank you guys for seeing this video, and yeah, I'm going to try to build much more interactive videos and articles so that you guys can also interact with Antarys and to see what we're doing. So yeah, bye bye.